Hi, this is your Professor Sudha Kolathuparambil, Section 8.4 Confidence Interval for Standard Deviation. This section has two objectives. Objective 1 is find the critical values of the chi-square distribution. Objective 2 is construct confidence interval for the variance and standard deviation of a normal distribution. Objective 1, find the critical values of the chi-square distribution. Most confidence intervals constructed in practice are for means and proportions. When the population is normal, it is possible to construct confidence interval for the standard deviation or variance. These confidence intervals are based on the distribution known as the chi-square distribution. It is denoted by x, kind of x and a square. But we read this as chi. This is a Greek letter chi. But we will pronounce this as chi. The method of this section apply only for the samples drawn from a normal distribution. If the distribution differs even slightly from normal, this method should not be used. There are actually many different chi-square distributions, each with different number of degrees of freedom. So this diagram represents the chi-square distributions for several different degrees of freedom. There are two important characteristics of chi-square distribution. First one is the chi-square distributions are not symmetric. They are skewed to the right. The values of chi-square statistic are always greater than or equal to 0. They are never negative. Notations for critical values. So if this area represents 1 minus alpha, sum of these two areas is alpha and each the shaded area is alpha over 2. The notation for the critical values are like chi-square alpha over 2, chi-square 1 minus alpha over 2. This tells us how much area is to the right side of the critical value. Find the critical values using the chi-square distribution. We need to find the critical values for 95% confidence interval and 10 degrees of freedom. So this area is 95%, that means 0.95. So sum of these two areas will be 5%. So 5% if I divide by 2, I'll get 2.5%, that is 0.025 in decimal. So this area is 0.025. This one is also 0.025. If we are writing chi-square 0.025, that means it has an area of 0.025 to its right. So that means that will be this one. So if you add, this is 0.025 and this one is 0.95. So if you add those two, you'll get 0.975. So this one will be chi-square 0.975. So this chi-square will have an area 0.975 to its right. Now we will find the critical values using chi-square table A4. So find the intersection of row corresponding to the degrees of freedom 10 and the column corresponding to 0.975 and 0.025. So now we can conclude the critical values are chi-square 0.975 equal 3.247 and chi-square 0.025 equal 20.483. And remember, the notation for the chi-square values tell us how much area is to the right of the critical value. Objective 2, construct the confidence intervals for the variance and standard deviation of a normal distribution. Let S square be the sample variance from a simple random sample of size n from a normal population. The level 100 times 1 minus alpha percent confidence interval for the population variance sigma square is between n minus 1 S square divided by chi square alpha over 2 and n minus 1 S square divided by chi square 1 minus alpha over 2. And for the confidence interval for the population standard deviation sigma, so sigma is between, take the square root of each one. So these are the formulas we use for constructing the confidence interval for the population variance and the confidence interval for the standard deviation sigma. When constructing a confidence interval for a variance or standard deviation, the number of degrees of freedom is always 1 less than the sample size. This is an example of constructing confidence interval for the population standard deviation. The compressive strength of 7 concrete blocks are given. So n equal 7. And it is measured in pounds per square inch. Assume these values are simple random sample from a normal population, and we need to construct a 95% confidence interval for the population standard deviation. Confidence interval for variance is this formula. Since we know n equals 7, so n minus 1 will be 6. Now we need to find S square as well as the critical values. So let's find the sample variance S square. You can use the calculator to find this. In the calculator, first press Stat, then select Edit and list all these values in L1. Then press Stat again, then Calc and select the option one word Stats and press Enter. Then you will see Sx equal 51.960222288. Then if you square that, you will get the sample variance. So here I didn't round this Sx, I used the entire value with all the digits, then I squared that. Then I round the final answer only. So do not round the middle answer, round the final answer only. So I rounded the sample variance S square only. Step 2, find the critical values. We have n minus 1, that is 7 minus 1 equals 6 degrees of freedom. Since the confidence level is 95%, the critical values are in the chi-square distribution table. Look at the degrees of freedom 6 and the column correspond to 0.975 and 0.025. So these are the critical values. Now compute the lower and upper confidence bounds. So now we can write the sigma square is between these two values. To find the confidence interval for sigma, take the square root of each one. So sigma is between these two numbers. Now we can interpret the result. We are 95% confident that the population standard deviation of the strength of the concrete block is between 33.48 and 114.4. The method of this section apply only for samples drawn from a normal distribution. If the distribution differs even slightly from the normal, these methods should not be used. In this section, you learn how to find the critical values of chi-square distribution, how to construct and interpret the confidence interval for the variance and the standard deviation of the normal distribution. And for level 1 minus alpha confidence interval, the critical values are denoted by chi square 1 minus alpha over 2 and chi square alpha over 2. So if you have chi square alpha over 2, this critical value tells us how much area is to the right side of the critical value. So this will have an area alpha over 2 to its right side of the critical value. And the formula we use to construct the confidence interval is, and for the variance, just take the square root of each one.